the same members of CECS groups like Form 2, chemistry for energy conversion and storage. And of course, we are working on the same topic of research for some kind of catalyst that we can use solar light. Okay, it seems something like we are using solar light and electric, okay, to promote the catalyst for some reaction like water splitting. Okay, I think Phong is introduced you about the water splitting, right? So it's the process of moving water to become hydrogen and oxygen. Okay, and this is it could be a reaction, important reaction for the futures, since you have to move the energy resource from the fossil fuel to hydrogens, right? Hydrogen is a kind of clean energy, you could say like that. But the trouble of technique, in terms of technicals, since the reduction of protons from water and oscillation of the oxygen there to get oxygen gas is a hard manner. Okay, so that reaction, especially in the case we are trying to use the solar light to drive this reaction, is not really easy at this moment. So we hope that in maybe in 50 years more in the futures, we can scale up this kind of research into the industry and promote, of course, promote the use of the hydrogen energy. Okay. So I am also taking care of some subjects, mostly for fundamental and applied science departments, chemistry program, of course. For example, polymer chemistry is my main field. I also take care of some other courses like organic chemistry, biomaterials, and the chemistry of surfactants. So you see that, have you ever seen surfactants and the importance of surfactant into the human life? Actually, most of the household products and personal care products around you, okay, especially for girls, for the case of cosmetic, for examples, there are some application based on the theoretical of the surfactants. Okay, so I see in the slide of Phong, you have you were introduced about the solution, about the colloidal system, about the solution, right? And to form the colloidal system, in the case of cosmetic, for example, like a shampoo, okay, like toothpaste, you have to use surfactants. Okay, of course, if you want to know more about that, join us. Okay, just feel free to join us anytime. This course will be introduced to these 3 students, not you now, but I hope that you will feel enjoyed with some chemistry course in USDH, because it's totally different with the chemistry in high school. I could say that. Okay. So I am okay. Let's share to you some of the information about the chemistry in university. Okay. So as normally I will take a tutorial class. For this year is the L11, L12. And normally the very first word I say to the student is, let's help me to remove out of your mind some kind of exercise like you burning something. Okay, so you don't have to burn any ester, any acid, any amino acid in USDH. Okay, so you will never see any kind of reaction like you have a mixture of 2 ester, 1 acid, and you burn them, and then you get some CO2, some water. Okay, and then you recalculate the structures of the ester acid. Okay, no, you will never see this kind of exercise here. Why? Just because we don't have to burn anything at this moment in science, in chemistry. Okay, if you want to know about the structures of any compounds, we have a lot of technique to do that. So we don't have to burn it, right? You can use infrared spectroscopy, NMR spectroscopy, is nuclear magnetic resonance spectroscopy, or Raman or XPS, anything. And they can give you the very precise structures of compounds. So we don't have to, based on the CO2 and water, to recalculate it. We'll never see something similar in modern chemistry. The second thing, the second kind of exercise, let's remove out of your mind, is the real thing of something. If you have a non-labeled chemicals in the laboratories, okay? So if you have that case in laboratory at this moment, my first work or our first work is asking your friend or your colleagues there, if they know what are they, fine, good. You label it again. But if no one knows what are they, so just let's wait it. Okay, you don't have to do the realizing of something of chemicals in laboratory at this moment. Okay, so let's remove out the kind of exercise. Okay, for the modern chemistry at this moment, let's focus on something like the structures. Okay, the structures of molecule, of atoms. So the relation of the structure to the properties, not a kind of the calculation exercise. Okay. So in this part, tutorial of exercise or the period today. So I will give you some kind of questions. Okay. There are 30 questions from sent me, and you will have around 1 minute and 50 seconds and 30 seconds, sorry, to solve the answer, to solve the question. Okay. After that, I will give you the answer. Okay. Let's keep in mind your results and compare to my explanation. Okay. To define that you are right or wrong. Okay. This kind of question will be the representation for the midterm test of you. It's okay?
All right.
Yes.
So how do you feel about the very first part of general chemistry of form? Is clear?
Yep.
So it's good. Thank you. Can we start now?
Yes.
Okay.
Yes, we can.
Yeah, let's move. So the very first question is something like that. And this one, as I said, is type of question for midterm test, right? Of course, the question of the midterm will be not the same here. So it's similar. Okay, so I will give you a clock, okay, to count down the time before I explain it to you. So let's take a look on the questions and solve it, answer it, and I will explain.
So do we send you the answer or?
No, you don't have to send me the answer.
Okay.
Okay, just keep it in mind to compare with my explanation. So, okay, So now you have, do you have the answer now?
Yes.
Yeah, it's a very simple question, right? So let's make clear about some of term of definition here, that including the elements, okay, substances, okay. After that, we'll take a look on what is a homogeneous mixture, heterogeneous mixture. Okay, so what is elements? Element, they have two meaning. In terms of element, you have two meaning. Okay, the first means of the elements is related to the periodic tables. Okay, if you have some symbols in the periodic tables like carbons, oxygens, fluoride, something like that, so it's the elements. Okay, so this one is the represent for one atom of that set of elements. Okay, the second thing, the elements is a kind of matter, but they made by only one type of atoms. Okay, for example, an element can be considered as a hydrogen gas, H2. This guy is made by two hydrogen atoms. Okay, similar to the case of O2, F2. Okay, so this means that if you have an element, this one contains only one type of atom. Okay, the second one, the substance. The substance is actually a big matters related to the matters. Okay, of course, substance will contain an element, as I said to you, like H2O2, F2. Okay, in another side, they will contain another kind of the matter of molecule we call a compound. Okay, the compound is a kind of molecule made by different type of atoms, like water. Okay, water, CO2, CF, okay, CF2 many times, like this guy. Okay, CF2 many times here is namely polytetrafluoroethylene or Teflon. Okay, if you stay at home and you have a non-sticky pan, okay, the top layers of the non-sticky pan is made by Teflon, and this guy is have to to avoid all the sticky of the food on the pan. Okay, so the substance actually is represent for all the kind of matter. Okay, so it can be compounds or it can be elements. Okay, the next thing, homogeneous mixture. What is a homogeneous? The word homogeneous is mean that you will see all the thing in the mixture there, and you cannot realize or you cannot separate all the thing of the mixture. Okay, you see the mixture of H2 and O2 as one. Okay, of course it's transparent and you don't see clearly what is H2, what is O2 in the mixture. Okay, so this one is homogeneous mixture. Or in another case, when you dissolve sodium chloride, the common salt, in water. Okay, so in the very first time you put it there, sodium chloride is showed you is exhibit as the kind of the powders. Okay, you can imagine that. But with time, that powder will disappear, and the salt and the water from no taste to become salty. Okay, so the salty solution there, you see it is transparent and nothing there. It's exactly the same with water, with normal water or pure water. Okay, so we call that one is the homogeneous mixture. Heterogeneous mixture, the example is like the case of milk. Okay, so the homogeneous mixture of milk here is made by some very small droplet of lipids in water. Okay, so because of lipid in water, they are not dissolved together. So you will see that the solution of milk become blind. okay, or turbid. You cannot see through it. Okay, if you have a cup of milk and you're trying to see something behind the cup, it's impossible, right? So this one is an example of heterogeneous mixture. Let's make clear about the prefix homogeneous and heterogeneous. Okay, homo is the same and hetero is different. Okay. So now let's go back to the questions. Water. Now you have a water with a molecule of H2O. Okay, so this one is a kind of compound and can be considered as a substance, right? Right? So this one is a substance. It's not a mixture because of you have only one type of the molecule in water. Okay, so the answer of this question is C. Water is a pure substance. Okay, so if you have a, okay, we have to make clear about the word pure and mixture too. Mixture is when you mix two things together, okay, and they don't have any reaction. They stay or they exist in the same system without any reaction, like the hydrogen and oxygens. Okay, we see that hydrogen and oxygen can make the reactions together to form water, but actually, if you don't do some of the very first step, like making increase the temperature, for example, the reaction will never happen. Okay, so H2 and O2 can stay together without any reactions. So in that case, we will have a mixture. Okay, a substance or pure substance is a kind of matter have only one type of molecule. Okay, in the case of water, you have only H2O. All the poison in the system of water have a H2O structures. Okay, so this one can be considered as a pure. Okay. So any questions about that? No?
Nope.
Okay, very simple. Let's move to the next one. Now this guy is related to the homogeneous mixture, heterogeneous mixture, right? So let's take a look and answer. It's okay. So the question related to the air in Paris. Okay. So this one is in outside air. It's not that it means that you are not do any purification for the air in Paris. Okay. So normally the air will contain of some gas, right? Like oxygens, nitrogens, okay, CO2 and something. Okay. So firstly, we will consider that guy is a mixture of different gases. Okay. The second thing is in the air, you have not only gases like this, you will have some different thing, some other thing like dust. Okay, you have some of the water droplet, like the fog. Okay, very frequently happen in Paris. You see, it's a fog. Okay, so what does this mean? This means now you will have some solid stay in the system like dust, or some liquid stay in the system like fog. Okay, so they have a different in phases. So now you have a system similar to the case of milk I explained before. Okay, so air in Paris is a heterogeneous mixture. Okay. In another thing, don't make me feel confused. If you have another question like air in Hanoi, easy. Okay, air in Hanoi and air in Paris is the same. Okay, they are heterogeneous mixture. Don't say air in Hanoi is homogeneous mixture, but air in Paris in heterogeneous mixture. It will be a really funny answer. Okay, so let's move to the next one. The crude oil. No, so let's take a look at the question first.
Hello, teacher.
Yes.
Oh, I say I thought that the air, we can see clearly the components of the air, so it's supposed to be the homogeneous.
Sorry, let's speak louder, please.
The previous questions. So I thought that although the air contains all this stuff, but we can see really clearly, so it's supposed to be homogeneous. Can you explain more?
So now you think that you have to see something. So it can be you need to see something, right? To conclude about the answer. Okay. So this means that you say you think that you cannot see dust, you cannot see fog. So the air should be homogeneous mixtures.
Yes.
Actually, you don't see, you cannot see, but our equipment can see it. Okay, if you have time, to take the air samples, to go to some technique like light scattering or laser scattering, okay, you will see actually there are many dust, very small dust, smaller than you can see. Okay, it's move randomly in the mixture there. Okay, so in terms of scientific word, we cannot say the air is homogeneous, okay, because of the equipment demonstrate to us that this one is a heterogeneous mixture. Okay, so this one is also an advice to you. Don't believe your eyes in science. Okay, let's believe your equipment. Don't believe your eyes. Okay, because of something you see, it's not the real thing happen inside the system. Normally, we are working on chemistry. It means we are working on some very small substance, very small molecule, and you cannot see it. Okay, so you see water, you see a liquid there, but you cannot see the molecule of water contain one hydrogen. Two hydrogen and one oxygen. Okay, but that molecule of water, H2O, still there, right?
Yes.
Okay, so let's help me to remember. You cannot believe your eyes in science. Okay, let's believe your equipment or believe to your characterization. Okay, so let's go back to the question here. Okay. Okay, so this question related to the crude oil. Okay, crude oil is a mixture of straight and branch chain aliphatic hydrocarbons. Okay, so they will start with the mixture including CH4, okay, methane gas, C2H6, and something. Okay, you can increase in the alkanes groups. Okay, they also contain some other hydrocarbon, including benzene. Okay, and derivative of benzene. Okay, so sometimes you can see some of very long chains like C80, H162, something like that. Okay, so in thermochemistry, all the kind of hydrocarbon here have a similar properties. Okay, so if you have a sum of the liquid hydrocarbon like a C8, it's 18. Okay, the gas line you are using outside. Actually, the gas of CH4 can dissolve very well in the system or the liquid of CH, it's 18, sorry. It's okay. Okay, so this question, crude oil here, is a hard question. I could say like that. Okay, it's a very hard question to define this one. Of course, now it's a mixture, but it's quite hard to define. This guy is homogeneous mixture or heterogeneous mixture because of, I will explain to you. Okay, firstly, in terms of chemicals, chemical inside the crude oil, as if you have only this guy. Okay, we can consider all the gases phase like CH4, C2H6, okay, all the kind of solid phase like a long carbon chains, okay, can be dissolved very well in the liquid phase of the shorter carbons. Okay, so in that case, we can consider crude oil is a homogeneous mixture. Okay, if they are dissolved well, this look like the case I said to you before, sodium chloride dissolved in the water. Okay, so we can consider this one a homogeneous mixture. But actually, crude oil is not only contain hydrocarbons. Okay, normally crude oil is not contain only hydrocarbons. They also contain some other thing like solid dust, okay, like sand, like sometimes water. It's okay. So if you consider crude oil only a mixture of the aliphatic hydrocarbons, okay, we can say, okay, that guy is homogeneous mixture. Or if you make crude oil from the mixture of different hydrocarbons here, we consider this one is homogeneous mixture. But if you consider crude oil, take from the crude oil minus, okay, from on the sea, for example, this one exactly a heterogeneous mixture because of they contain many things inside. Okay, so in this one, in this kind of exercise, I prefer the answer is a heterogeneous mixtures. Okay, because of the real thing, crude oil in the real state, crude oil is heterogeneous mixture. Okay. It's okay.
Yep.
Next. Which one correct? So I think this kind of question we should use only 30, only 1 minute is enough. I think. So which one is correct, Mr. Cuvelier David?
The correct one is A,
Mhm.
because
Can you
weight
explain?
depends on gravity and mass doesn't.
Perfect. Okay. In that case, in that expression, you have to define the difference between mass and weight. Okay. The mass denoted as M normally have a unit of gram, kilogram, something. Okay, and it's exactly show you about the how many, I could say how many or how much of the molecule in that box. Okay. So mass is a properties of substance or property of compound. Okay, but the weight, this guy, it depends on the gravity, and the weight normally calculated by mass multiplied to the gravity, and the unit of weight normally is Newton. Okay, so in the case of weight, not only is depend not only mass, is depend on gravities, and the gravities on the planet and the gravity on the space is totally different. So you will have a different weight of one substance. Okay, but the mass is the property of that substance, so they are the same. Okay, so the right answer here will be A. Astronaut will have an identical mass, but they will not have an identical weight. Okay. Be careful, this one is not correct. Okay, what about your answer? I will ask another guy. Huỳnh Ngọc Linh, please. Are you there?
Yeah.
Okay, Linh, what do you think about these questions? Huh? A is not correct. It's not correct, right? Anything else? Because of the question here is is or are, so you may choose many
A
answers.
and B. A and B.
A and B. Are there
Also
anything
C.
else? Also C. And what about D?
D2.
Yeah, that is
D,
correct.
D correct or not correct?
Correct.
This one is correct. This one is not correct. It's okay. You're right. Okay. There are three statements is not correct in this case. Okay. Solid, liquid, they have not a fixed volume. Okay. The volume of liquid and solid depends on the temperatures. Okay. So actually, they depends on the arrangement of molecule in the system, and the arrangement of molecule in the system will depends on temperatures. Okay. For example, in the case of solid, you have some crystal inside the solid, for example. Okay. And when you increase the temperatures, because of the movement increase, okay, you give more energy to the system. Now the molecule vibrate more or move easier, okay? So normally the solid will have the trouble of extending the bond between them or the distance between the molecule. So sometimes, so mostly they will expand the volumes, okay, or increase the volume with increase the temperatures. Not so much, but it's increased. Okay. In the case of liquid, you have the same thing. And the next one for the statement C, liquid takes the volume of its container. No. Gas will take the volume of its container. It's fulfill all the containers. Okay. Liquid only fulfill the bottom part or lower part of the container. Okay. So it means that the liquid can represent to the shape of the container, not the volume of container. Okay. So first one wrong, and this one is right. Because of the gas, they can fulfill all the container. Okay. It means that the distance between the gas molecules, okay, is not identical. It's not fixed. So if you have a very big container, the distance between gases will increase. But if you have a smaller containers, the distance between the molecule of gases will be decreased. So you can increase the pressure to make the gases become smaller, or the volume of gases become smaller, or increase or decrease the pressure to expand the volume of gases. Okay, so the D is right. Let's move. Okay. So what about your answer, guys?
Maybe increase the pressure and also reduce the temperature. That's the most efficient way.
It's okay, perfect. Okay, so in the case of if you want to liquidify gases, okay, normally you have to increase the pressures and reduce the temperatures. Reduce the temperature is quite simple and easy to understand, right? Because of like the case you burn, like the case you boil water, okay? At 100, the water will evaporate, okay? So it's moved from the liquid form to the gas form, okay? After that, if you cool it down to the lower temperatures, the gas form of water will precipitate or condense again to become liquid, okay? So reduce the temperature is exactly the good way to do that, okay? But in the case of increase the pressure, this one is a little bit harder to imagine in the real state, okay? This one will be explained to you more clear in terms of the general chemistry too, when you study about the about the partial pressure on the surface of the liquid and solid. Okay, so normally the process of moving the liquid to the gas phase, this means that you are increase the pressure, okay, of the surface of the vapor pressure of the liquid equal to the pressure in the gas phase. Okay, and so I know that it's hard, but normally when you increase the pressure, you will let the partial pressure come from the vapors or the gas of hydrogens become lower and lower compared to the in terms of the ratios, okay, compared to the whole system. So when they do something like that, you will press the molecule of hydrogen become closer, okay, and increase the pressure on the surface, on the gas phase compared to the liquid. So you will let the hydrogen in the gas phase transfer to the liquid form, okay, to reduce the pressure. Okay, so it's a little bit hard to remember at this moment, but in the next semester when you study general chemistry 2, you will make it more clear. Okay, so the answer for this question, for all the kind of question, when you want to liquidify or solidify something, okay, from the gas to liquid to solid, okay, normally the process here in this direction is increase pressure and decrease temperatures, and in the reverse way, from solid to gas, you will decrease pressure and increase temperature. Okay. The next one. Okay, guys, when you look at the diagram here, what about your answer? Sorry, I have to reduce the time of your solution to 1 minute, okay, to be sure about the timetable.
It's B.
It's B.
B.
Okay, so thank you, Mr. Right one. Okay, so let's take a look on the diagram here. The diagram here is showing you about the freezing point of the solution of sodium chloride. Okay, so it means that when you increase the concentration of sodium chloride, okay, the freezing point on the temperatures for sodium chloride solution from liquid to be solid will decrease. Okay, this one is named the freezing point. So the process of moving is of using some sodium chloride to dissolve or to melt the snow is not really happen a lot in Vietnam, but it's not happen frequently in some colder country like China, like France. Okay, if you have time to go there in the future, you will see in the winter the French, they will use some of the sodium chloride. So, okay, just put the straw on the snow and they will be melt down. They base on the idea, they base on the properties of the solution we call the colligative properties, that if you increase the concentration of something in the water, Okay, you will decrease the freezing point. You will make the freezing point of water below 0, and also you will increase the boiling point. This means that you will make the water move, transfer from liquid to vapor at higher temperature than 100 Celsius degree. Okay, and the diagram here shows you that the temperatures of freezing point will decrease. Okay, so you see the temperature outside in Paris defined at -5 Celsius degree. This means that now the snow have a temperature of -5, and if you want that snow transform to the liquid at -5, now you need to add sodium chloride there. Okay, to be sure that the solution of sodium chloride in water have a lower melting point than, lower freezing point than -5. Okay, so -5 is here. Let's move to this point on the diagram, on the curve, and then we're moving down to the horizontal axis. And by that way, we can define the postseason or the concentration of solids of the sodium chloride solution have the freezing point of -5 is around, let's say, is 8%. Okay. So in the question, in the answer here, you have question, sorry, answer B. You add the sodium chloride into snow about 10%, 10% here, and the freezing point of the system now become lower than -5, right? So it's a good answer. Okay, of course you can choose another answer is do nothing but stay at home. No, just kidding. Okay. Next one. Have you seen this question before? Phong explained to you about supercritical fluid.
Yes, it will be
Yes,
yes.
Yes.
Okay, perfect. So the answer is?
The answer is C.
Sorry?
The answer is C.
C.
Do not purchase the machine, it will not work.
Can you explain?
Because to reach to the critical point of carbon dioxide, you must get the temperature at 31.1 and the pressure at 74, but the machine can only reach to 60 atmosphere. It can make CO2 reach to its critical point.
Okay, good. So in this case, when you look at the CO2 phase diagram, you will see a critical point. For CO2 to become supercritical fluid, they need the pressure at least 74 atmosphere. Okay, 74 atm. The temperature is 100 is more than enough. But the maximal pressure of the machine is only 60 atm. So they only reach to something here, okay? And which will be lower than critical point. What does this mean? This means that that machine will never can transfer CO2 from the gas phase to the supercritical fluid. Okay, so if you have a right to recommend, you will say, do not purchase the machine, it's not work. Okay, perfect, thank you. Next. What is your answer? So the global energy consumption is a very big trouble or big topic on the world now, right? So you know that the trouble of the human life in this moment is we are lacking a fossil fuel and they will be disappear soon. Okay, actually it's not a real story, but let's consider that fossil fuel will disappear soon. Okay, so to deal with these problems, actually there are two kinds of the study is moving. Okay, they are moving in parallel. The first one is invent new shock of energy. Okay, we are trying to find a new shock of energy. Okay, we even don't know what is that. It's like many years ago we don't know about the nuclear energy. Okay, and even another thing, in another way, we are trying to harvest the energy which are already available on to the human being. Okay, for example, you still have a lot of the energy resource. We are not harvest them in high performance enough. Okay, for example, wind energy, for example, the solar light energy. Okay, so it's the trouble of the technology. It's the trouble of technology at this moment. Okay, for example, the solar panels. Oh, sorry. The solar panel or solar cell in this moment, they only reach to around 30% of solar light. This means that if you have 100, how to say, if you have 100 energy unit from the solar light, the highest technique of solar panel at this moment that can gain to you only 30 energy unit. Okay, for our research, for example, in the case of using solar driven for the water splitting process, okay, the performance of that process is only 3 to 5%. Some group on the world, in like the group of Jaramillo in the UK, in the United States, or the group of Professor Domen in Japan, okay, they only reach to several percent for that process. So it means that we still have a lot of energy resource, but we need to improve our technology to harvest them in higher performance. Okay, so the main idea for this one is the harvest of energy. which are already available for the human being. But of course, in this question, you can choose A and B for the answer. Okay, because of they are two directions of research at this moment. It's okay.
So in the midterm test, do you know? Will we know when is the multi-answer question and when is only one correct answer?
Normally, you will not know. Okay, so this one is a kind of the question too. Normally, we only say to you that this test, okay, is a multi-choice questions, and the multi-choice question have a multi-answer. Okay, we will not say exactly this question have a multi-answer or that question have multi-answer. No.
So if we select like too much answer or we don't select sufficient answer, that is that count like a part, like some points for that question?
This one will depend on form. Okay, normally if you lack of for example, the question have two answers and you only point one, it's okay. Normally we will keep for you a part of a point. But if you if the question have only one answer and you fill all like this, of course you will have no point for the questions.
Okay.
Okay. Okay, next questions. And I think this one is just make you 30 seconds. Okay, what was your answer?
A and E.
A and E. Can you explain?
So it's transfer the energy transfer from chemical energy into kinetic energy. So to the car.
Mm-hmm.
And
it's not kinetic energy, okay, it's dynamic energy.
Pardon?
It's a kind of dynamic energy, okay, or motion energy. It's not kinetic energy.
Okay. And it's an exothermic process because it's produce heat.
Okay, thank you. So the burning gas line is what you are doing when you need to run on the motorcycles or car, right? So that process is you oxidize some of the gas line when you buy it from shop, okay, and then make your car running. So the energy in this case will be transformed from chemical to motion. Okay, energy stored in the gas line, and you burn the gas line, you get the motion of the car. Okay, so this one is the chemical to motion process. Okay, in another case, when you run your motorbike and your car, okay, after several minutes, you will see the machine inside your car or your motorbike become hotter. Okay, so you see, show you the information that the process of burning gas line is a process. Energy will be released out at heat. Okay, temperature increase. So it means that the energy will release out at heat, and the heat will make the temperature increase. Okay, that process is namely exothermics. Okay, in some other process, if you do some chemical reaction and you feel your container or your reactants become colder, that kind of reaction is namely endothermic, because of the energy of the system outside will be collected by the process. Okay, so the answer of this question is A, chemical to motion and exothermics. Okay, good, thank you. You feel clear?
Yep.
Of course, the process of burning gasoline or burning anything, they are not the energy efficient energy conversion, because of you produce both motion, right, and heat normally is lost out. Okay, so this one I don't think we need 1 minute. Okay, so dissolving, a process of dissolving. When we say dissolving, it means that we still have, or we make a mixture of something into a liquid. Okay, like the case I say, dissolving common salt of sodium chloride in water. Okay, so you generate a mixture. This means that there are no reaction between the solid of sodium chloride in this case and O2 in this case with water. Okay, so this one should be a physical process. Okay, a process can be appear or happen without any change of the molecule. Very simple. Okay, take a look on this question. Okay, guys, do you have any answer?
Argon would be the answer.
Yeah, sure. I know that with this question, we will not, you guys will not have an answer, because of this one is a process normally used in the laboratories. Sorry?
No, no.
So this process normally used in the laboratories. And if you don't have any experience in laboratories, it's very hard to answer these questions. Okay? So the process of moving or the dissolve oxygens in water, okay, normally is a process we call a bubbling in inert gas. Okay, so actually in this case we have to consider the first thing is inert gas. This means that that gas should not react with water, or even should not be dissolved in water. Okay, the second thing, this gas should be quite heavy. Okay, because of the bubbling process, normally we relate it to the density of the gas. If you have a very light gas like hydrogens, the time of bubbling is too fast, and the oxygen have no time to penetrate into the bubbles of the light gas like hydrogens. Okay, so normally in laboratories we will use nitrogens and argons. Okay, of course, why we don't use CO2? Because of CO2 dissolve very well in water, much better than oxygens, and even they will have reactions to perform it to CO3. Okay. So in this case, we will use the nitrogen and argon as the inert gas. to remove the dissolved oxygens. And the best choice will be argons. Okay, argon is heavier than nitrogens. So the time for the argon bubbles stay in the liquid form longer than nitrogens, and they will let the oxygen easier to penetrate into the bubbles of argons in the system. Okay, it looks like that. You have a solution and you have some oxygen inside. So you use a kind of tip, okay, and move argon here. So argon regenerates some of the bubbles and they move up to the surface. Okay, so because of argon is heavy, so oxygen will have time to penetrate into the bubble. It's okay. So it's what we are doing in the laboratories. And I also know that if you don't have any experience in lab, in chemical lab, it's very hard for you to answer these questions. Okay. When I said here, the best choice is argons, it's not really mean it's a suitable gas, okay? Because of argon is very expensive. So normally for some of the process, it's not really required a very good performance, very good or very low amount of oxygen in the system. We normally use nitrogens because of nitrogen is cheaper, much cheaper compared to the argon. Okay. One argon bottle, one argon liquid bottle we are using here have a price of 5 or 6 times of one nitrogen bottle. So normally we use nitrogens, but the best choice, okay, again, I will say the best choice is argon. Okay, this means that in that examples, also in that question, let's choose this one. Okay, it's the best inert gas for this purpose. Oh, do you see the answer? Okay, so do you see the questions?
Yes, we do.
Yes.
Okay. What's happened to my clock?
It's still working.
Mm-hmm. Do you have answer for this? You see?
It is a chemical process, but I'm not sure if it is exothermic or endothermic.
Okay. So I will answer for you. Okay. So the process here, if we consider all the time from the reactants or precursors to the products, okay, you don't have any process because of the reactant and the last product is the same. Okay, so it should not be any process. But if you consider the pathway, they are moving from the first state to the last state. Okay, now you will see it's transformed from the position of trans to the position of cis, and cis and trans form of even one molecule. Okay, they are the different compounds. Okay, trans polyisoprene, for example, or cis polyisoprene, they are totally different. Okay, so it means that moving from trans to cis is the chemical process. Okay, that process is making by the molecule absorb energy from the UV light. Okay, the energy from the UV light. Normally they will write as the H nu like that. Okay, so the UV light gives some energy to the system. The molecule absorbs the energy from the UV and transform in terms of chemical change, okay, to become another molecule. And after that, with tau times here, okay, we call this one is decay time, something like that. The energy from the molecule contain higher amount of energy, okay, or higher levels of energy. Now we release back, okay, energy will go out from the molecule, and the molecule go back to the original state. Okay, so we call this one is a molecule motion process, and we consider this one is a chemical process. Okay, in terms of exothermic or endothermic, we will not have any conclusion in this case because of we don't have any information related to the temperatures. It's okay. Exothermic, endothermic process. If you want to conclude about that, you have to have information of temperatures. And in this case, we don't have information of temperatures, so we cannot conclude anything to the endothermic or exothermic process. Okay. Next, this question is come from the lectures of Fong, right?
Nope.
Nope. So I think I have to increase the velocity, the rate of the summation because of we have only 30 minutes more, right? So when you read at the exercise, you see you have a mixture of CO, carbon monoxide, and hydrogens, a mixture. Okay, and the trouble is when you use the mixture of hydrogen and CO for the proton exchange membrane, okay, of the fuel cell. You see some car outside, okay, we call the hybrid car, for example. Hybrid car is a car combine the electric engine and the gasoline engine, okay. And in the very near future, you will see the type of car we call electric car, but use the energy or electric come from the fuel cell. Okay, the fuel cell is the reactants in which they will use the hydrogen and oxygen for the reaction to make water with the platinum as the catalyst. Okay, and this process will release energy for car, okay, as an electric. So the trouble is the CO, the carbon monoxide, they have a trouble we call the poison of the catalyst. This means that CO can bond with the catalyst or PT here, much stronger than hydrogens. Okay, so when the CO poison or block all the surface of the catalyst, platinum in this case, the hydrogen will not work in this reaction anymore because we don't have catalyst more. No, right? So the process to reduce that trouble is actually is based on is appear in the question 2. Platinum. We will use a nanoporous filter of platinum. Okay, because we know that platinum can bind carbon monoxide much better than hydrogens. Okay, so you will have a filter of PT. The mixture of hydrogen, CO pass through it. All the CO will be stuck here. Okay, and release hydrogen out. This one will go to the fuel cell for water and release energy as the electric for car. Okay, so the main process here is use a nanoporous filter made of platinum. Okay. Some other answer here, like use of copper in replacement to platinum, is not fit because of copper cannot bind carbon monoxide like the platinum. Okay, when you burn the mixture with oxygen, it means that you will not have a hydrogen for the fuel cell anymore. Okay, and lastly, flux the mixture through a calcium hydroxide solution, and the trouble is that CO and H2 is not dissolved very well in that solution. Okay, so it's useless. Okay, so the best work here is A. Okay, simple question and answer immediately, please. Mr. Dat, please. BA11019.
Okay. I just see. I remember the minus 16 power. Minus 16. So C.
Be careful. Okay. You are answered the wrong thing. Totally wrong thing. Okay. So let me give you the answer. So 10, we base on the main unit of the distance is meter, right? If you have 1 centimeter, this can be considered at 10 minus 2 meter, right? 1 picometer, this is 10 minus 12 meter, okay? 1 nanometer equal to 10 power minus 9 meter, and 1 micrometer, you see, 10 power minus 6 meter. Okay, so the answer is B, picometer. Okay, very simple.
Yes.
So don't be confused about that. Okay. Now let's move to the accuracy and precision, and give me answer, please. What happened for A, B, C, D here? Okay. Low accuracy but high precision.
Is that B?
It's B. Okay. Accuracy is shows you that your result is close to the real results or not. Okay. So it means that if you have a result of experiments, it stay in the very close to the real results. Okay. This means that you have a high accuracy. The precision is give you the information that your result is close together or not. Okay, it's close together or not. Or they will say to you about the repeatability of the experiments of you. Okay, if you are a very good researchers, okay, you can reduce the bias come from you. Okay, so you can do the several experiments, but you have the same or similar results. We call this one is high precision. Okay. So low accuracy is mean that the result will be very far from the real one. Okay, like this, you have the real result is in this position, but you have a result of the experiment is very far from this. Okay, but your result is very close together. This means that actually now this experiment have some systematic bias. Okay, some bias you cannot avoid. Okay, so B is is the answer for the low accuracy but high precision. D is the high accuracy, high precision. Okay. A is low accuracy and low precision. And this one, C, is a low accuracy, okay, sorry, medium accuracy, but also medium precision. Okay. Significant figures. How many significant figures here?
One.
There are one. Only one significant figure is number 9. So significant figure, let's help me to remember or keep in mind that significant figure is the way for writing down the scientific notation. Okay, scientific notation will be the numbers with the formulas of A multiplied to 10 power B. Okay, with A run from 1 to 10. Okay, so it can be 9.9 something multiplied to 10 power 9, something like that. So this one is the scientific notation. And the A here will be the significant figures, okay, or the numbers of A. The number of figure of A will be the significant figure, the number of significant figures. For example, 0.009 here can be redrawn as the 9 multiplied to 10 power minus 3. Okay, so you have only one significant figure of 9. Okay, now you remember? So there are several rules of significant figure is if you have a 0, stay. Let's take examples. This may be easier. 0.0009090000. Okay. So there are several rules. If you have a 0 stay before significant figures, this will not be counted as significant figures. Okay. So it means this one is the no significant figures. Okay. If you have a 0 stay in between two significant figures, this one becomes significant figure. Okay. And in the case 0 stay behind or after the decimal point. Okay. And after significant figures, this one still significance. Okay.
Professor, can you mute BI 12428? He's making a lot of noise.
Okay. Sorry about that. Okay. In another side, if you don't have the decimal place here, for example, 400. Okay. If 0 stay behind or after significant figures without the decimal place, this one become non-significant. Okay. So it means that the first word I write here can be redrawn or rewrite as 9.09000 multiplied to 10 powers minus 4. Okay. And the second one, 400, can be redrawn or rewrite as 4 multiplied to 10 power minus 2. Okay. The first one we have a 1, 2, 3, 4, 5, 6 significant figures, but this one have only one significant figure. Okay.
But why the first one we can't eliminate the 3 0 after the 9?
This guy, right?
Yes. Why?
As you remember, let's have me to remember. Significant figures is the numbers of significance values of numbers. Okay. Okay. So in this case, when you write 1, 2, 3 zeros here, actually you are sure that the results is come from 1, 2, 3, 4, 5 position. Okay, you're only not sure about the last value. Okay, so it's the reason why this means that this one can be, okay, this one can be different than 0, and this can be become a significant values, okay, of significant numbers. Okay, as you remember in the definition of significant figures, when you have a ruler, for example, okay, you see 7 and 8, for example, and you have a bar of wood, is something like that. Okay, you only know, you don't have the scale in between 7 and 8. Okay, so you just know that the length of the bar here is longer than 7, but shorter than 8, right? So it means that this guy, you can write it's 7 something. Okay, it can be 7.5 with the word 5 here is the estimated values, because you don't know exactly, right? It can be 5, it can be 6. You only sure about 7. Okay, so in this case, you will have 2 significant values. If the length of the, even if the length of the bar here is very close to 0 here, okay, you can write it 7.0. But you still don't know that it's exactly 7.0 or 7.1 or 7.005. Okay, so the values of 0 after the decimal place become significant, okay, when they stay in the last part of the value. Is the reason why we cannot eliminate or neglect 1, 2, 3, 0 in the last part after the comma. Okay.
Okay.
So next one. Now this is related to a kind of the some of calculation, right? Calculation based on the significant figures. Of course, this one will based on two theoretical rule that when you do some addition and subtraction, okay, this means you have a plus or minus. We need to consider about the significant figure after the decimal place. Okay, after decimal place. So, for example, you have the city 04 here. Okay, the length of city 04 will become, let's consider this one is 1, 2, and 3. We equal to 1 plus 2 plus 3. Right? Right? So the rule for the calculation of addition and subtraction is if you have the less numbers of significant figure after the decimal place, For example, in this one, number 2 have only one significant figures after the decimal place. This first one have a 2, the next one have a 3 significant figure after the decimal place. Okay, so in the results, we will keep the results of the sum or the subtraction have the same number of significant figure to the lowest significant figures of the components. Okay, so in that case, this one have only one significant figures after the decimal place. So in the results, we need to keep only one significant figure after decimal place. Okay, so the result will be
T.
B.
what's happened?
C.
C.
You have only one significant here. Okay, this one have a 2, this one have a 3, and you have to keep the number of significant figure after the decimal place of the results as the same with the shortest or the smallest values of significant figures. Okay, so this one have only 1, so it means in the result you need only one significant figure. Okay, so it's become this guy have only one significant figure after the decimal. So the answer here is C. Okay, if in the case this guy is they do the better work. Okay, some guy is they are measuring the distance between Hưng Yên and Hải Dương. If they are doing the better work, they will say this one is 28.18 kilometer. Okay, now they become two significant figures, so maybe the values will become that guy. Okay, but because of he quite lazy, or they are quite lazy, so they are doing only one significant figure after the decimal. So the result will be this guy, C. It's okay. Okay, so now this one is quite similar. You know that the density D equal to mass multiplied to volume. I'm sorry. Density equal to the mass divided to the volume. Right? So
Yes.
the mass will equal to D multiplied to V. Okay, density multiplied to the volume. So now you have another rule for the calculation. For the multiplication and division. Oops, sorry, I don't know what's happened. Okay, multiplication and division. So multiplication and division now is depends on the numbers of significant figure, whole significant figure before and after decimal place. Okay, for example, here you will have a mass of tungsten equal to D multiplied to V equal to 1925 multiplied to 10 power 7. Sorry, 10.7. Okay, the first one have a 4 significant figure, and this one have a 3 significant figure. Okay, so the result will be something have only 3 significant figure. It's okay. So result should be round up to get only 3 significant figure. So what is the result now?
A. E.
The result will be E. Okay, only 3 significant figure. Even you will see it's a very, how to say, very funny result. It's okay. So in the exercise of the tutorials class, you will see some of very funny calculation of using significant figures. And the story of significant figures come from many years ago. When you don't have, or scientists, they don't have a calculator like this moment. So they have to round off, they have to limit the numbers of calculation for the easier process. But now you have a calculators. Okay, you have a phone, you have a laptop, you have a calculator everywhere. So just use just use all the values, okay, calculated by calculators, and then round up as you want. Okay, if you think that this measurement should have a 5 values after the decimal. It should have 8 values after decimal, for example. You round up at 5 position or 8 position after the decimals based on the results on the calculators. You don't need to round up in every process or every calculation. Okay. Okay, the next part we related to atoms. So, correct, right? Atom is indivisible. Is right or wrong? It's wrong. Okay. Atom can be devised, can become smaller. Atom is a building block of all matter. We can say atom is a building block of molecule, not matter. Okay. The nature of atom will change in the chemical reaction.
Nope.
No. Okay. Atom still atom in the molecule, even in the chemical reaction. The only right here is the nature of atom will change in the nuclear reaction. Okay. In the nuclear reaction, you will change the number of protons or neutrons in the nucleus. And from that, you will move the first atom to become another atom. Okay, so the nature of atom only changes in the case of nuclear reaction. Like a nuclear bomb, you know, in Hiroshima and Nagasaki before, okay, in World War II. Okay. Correct. Atom extremely small. It cannot be observed. You think it's right or wrong? It's right in the case of it's right in the case of you use your eyes. Okay, but with some of the very good technique of the electron microscope, for example, at this moment, like the dark field electron microscope in this moment, you can see atoms sometimes. Of course, we need to see some big atoms, not very small atoms. Okay, it can be seen sometimes. Atom size. This one is right, correct.
So can you mute everyone again? Someone forgot to turn on the mic. Thank you.
I think that which following statement here are correct. Okay, we are thinking about the movement, the observation of atoms. Okay, and you know that atom is very small, as the size is around 100 and 500 picometer. Okay. So the trouble is you cannot see it by your eyes. You also cannot see it by some of very simple technique like optical microscopy. Okay, but with some new technique at this moment, like transmission electron microscopy (TM), okay, or dark field transmission electron microscopy HAADF TM, STM. Okay, we can see some of atoms, not all. Okay, some big atoms like a transition metal, we can see it. Okay, we can define it, not really see. Okay, but for some smaller molecule or smaller atoms, you cannot see. Okay. In the second thing, so this one is quite okay for the answer. Okay. In the second one, we can observe the movement pathway of electron even in the dimensionless. Okay. Actually, we can. Okay, we can, but we have to do some calculation. For example, you see the electron is the negative charge. Okay, the negative charge. So we can control the movement of electron by using two potential, by using a potential like this. Okay, this one is positive, this one is a negative. So you can move electrons beam with negative charge in this way, go through the tube with a potential like that, and the electron will be attracted by the positive charge. So you will see the electron move like this. It's okay. So with some technique, we can observe the movement pathway of electron, even if the dimensionless is right. It's okay. But of course, the process here is a calculation, not really see. You can predict and calculate to observe the movement of electron. Okay, so this one is so simple. Atom is constituted of electrons, neutron, and proton. Okay, in which neutron and proton will stay in the inner core we call nucleus. Okay, and the electron will move around electrons. Okay, move around in the shell of the atoms. And of course, the thing is the electron is not move on one orbit. Okay, so normally you cannot take a pictures of electrons, but you can see electron move very fast around the nucleus as a cloud. It's okay. What time we have to finish the
9:25.
9:25?
But normally there is a
9:25?
pause between this class and another class, but maximum we have is 9:25.
Okay, so I think I will try to finish at 9:20. Okay. Of course, we will have some other exercise cannot be answered at this moment, but fun we have you for the last part. It's okay. Another statement correct in terms of the nucleus. Sorry, of the atoms. So in atom, you always have a neutral charge. Okay, neutral charge is mean that the number of positive charge and number of negative charge in the atom are equal. Okay, this also leads you to an information that the number of electrons equal to number of protons. Okay. Another thing, the number of proton and number of neutron, they are not have any relation. Some atom have a higher, normally the number of neutrons will be bigger than the number of protons. Okay, so the difference in the number of neutrons, difference of number neutrons will give you the isotopes. Okay, for example, you have oxygen 16, okay, oxygen 17, oxygen 18. Okay, so in that case you will have 8 protons. Okay, in the first one you have 8 neutrons. Okay, second one you have 9 neutron, and the next one you have 10 neutron. Okay, so let's remember, in the atoms, the number of electron and number of proton are the same. And the difference in number of neutron will give you different isotopes. Okay? So the right results for these questions will be C. The number of electron and proton are always equal. Okay, in normal atoms. So properties are correct for electrons. Firstly, electron is considered as the point. Okay, electron always be considered as a point. You cannot count the dimensions. You don't know that the diameter of electrons. Okay, you cannot say about the diameter of electron. You cannot say that electron have a long edge or a small edge or something like that. Okay, this one is a point light. Okay, the second thing, electron always contain negative charge. So negative charge. Okay, even the electron, you cannot say electron is a particles because of this dimensionless. Okay, you cannot count a diameter of electron, so B is wrong. D also wrong because the electron is very light, and almost of the whole mass of the atoms here come from nuclear. Okay, it's either proton and neutron. It's not come from electrons. So let's finish with this one. Okay, properties of the nuclear. Okay, in terms of nuclear will be considered as the dimensionless too. Okay. Okay. Sometimes we can consider nuclear as very small particle with extremely small diameter. But in quantum chemistry, we also consider nuclear as a dimensionless, or they have a no dimension. Okay. The only thing we see, the only thing we see from the atom is the how to say, a cloud of electron move around nuclear. Okay, we don't know exactly where is the nuclear. So, okay, we can say about the diameter of atoms, but we cannot say about the diameter of nuclear or electrons. Okay, so nuclear considered as the point light particle with no dimension. Okay, nuclear contain of proton and neutron. Proton with the positive charge, and neutron is zero charge. So nuclear have a positive charge. Okay, and lastly, nuclear will take almost mass of the atom. Okay, because the proton and neutron is much heavier compared to the electrons. I remember that proton have the how to say, the relative mass compared to the electron is around 100,000 times. Okay, so we can sometimes we can neglect the mass of electrons as the whole mass of the atoms, in the whole mass of the atom. Okay, so I will stop here for the for you to prepare for the next course, and the other 5 other exercises will be solved by phone. Okay.